A very warm welcome from Faculty of Dentistry, Masa University, Malaysia. Hope you are doing well. I am Dr. Shulagna Datta, and today I am very glad to present to you a very interesting webinar. Well, you're doing well, and congratulations for doing well in this pandemic. Congratulations for striving so hard to achieve success in your walks of field. Today I am presenting you my colleague and friend Dr. Liu Fong Fong, who has worked very hard to achieve success in her arena. Okay, let me introduce to Dr. Liu Fong Fong. So, Dr. Fong Fong is a senior lecturer in the Department of Oral Biology and Biomedical Sciences of Faculty of Dentistry, Masa University. She is a very successful researcher who has done her PhD in fundamental energy science from Kyoto University, Japan. She has got of multivarious research grants, including the Fundamental Research Grant Scheme (FRGS), and has got 15 years of laboratory experience in the fields of biomedicine, chemistry, and green technology. She has previously worked as a postdoctoral researcher under the University Malaya Cancer Research Institute and Graduate School of Energy, Kyoto University, Japan. She has been actively involved in teaching in physiology and biochemistry in Masa University, besides being an excellent researcher. So, today we are going to get enlightened on one of our research topic, that is exosomes in wound healing. So, I would like to pass on to Dr. Liu Fong Fong to share her experience and share her knowledge with us today and get us and let us enlighten on this very important and essential topic. Welcome, Dr. Liu Fong Fong.
Okay, good morning, Prof, doctors, my fellow friends and students. Thanks, Dr. Sulagna, for introducing me. Today, I would like to take this opportunity to share some point of view on the challenges and opportunity in exosome-related research. Okay, exosome in wound healing. The topic that I'm going to discuss today are what are exosomes, where are exosomes found, exosomal cargo for wound healing, wound care management, and role of exosomes in wound healing. What exosomes are exactly? These are those tiny bubbles that call as exosome. They are a subfamily of extracellular vesicle. When we talk about exosome, definitely we can't run away from biogenesis, how the exosome is produced. It's basically through the inward budding system. It will form the intraluminar vesicle. And it will later will form the multi-vesicle bodies here. At this point, it will have two potential fate. The first fate, the multivesicle bodies will fill with lysosome and it will lead to the degradations. Another potential fate will be it will fill with the membrane and release exosome. How big is each exosome? It's about 30 to 150 nanometer. It's nano-sized particle. And it is very similar to unilamellar vesicle. This is ribosome. What is the differences between the exosomes and unilamellar vesicle ribosome? Ribosome can be produced by scientists, whereas exosomes are produced by cell. The function will be dependent on the cell origin, whereas for ribosome, we can determine the functions by doing modification and manipulations. Okay, what are another differences? Okay, when we look into the ribosome, basically it's empty. It has nothing. Whereas for exosome, it carries the multiple protein and genetic materials. Okay, so why exosome is important? Why is gaining popularity among researchers? Okay, one of the main reason is play essential role in cell-to-cell communication. Indeed, this is one of the gray zone that really encourage researchers to look into it. How the crosstalk between cell and exosome. Okay, at current, the mechanism that reported are endocytosis, direct binding, ligand receptor interaction. Who knows? If you try to look into this area, you will find something novelty. You will get some mechanism beyond these three mechanisms. Okay. Okay. Next, we will touch a little bit on the history of exosome-related research, the title of key discovery. Okay. The multiple vesicle bodies that I mentioned from beginning actually have been found, have been observed in year 1957 in algae, in fungi. Okay, but only till year 1977, this term extracellular vesicle used for the first time. And in year 1980s, okay, about 5 years later, okay, they observed the exosome. Okay, but by that time they thought it's just cellular waste. It means nothing. It has no life and no functional role. However, after 5 years, okay, in 1990s, researchers report on the presence of antigen presentation and immunological function on exosome. It means that the exosome itself has functional role. It's not just a waste from the cellular. People start look into the composition. They start look into the functional. Okay, and in year 2020 onwards, a lot of functional role of exosome has been researched. They look into the potential of exosome for chemotherapy. Okay, they look into the biogenesis mechanism that I mentioned just now. Okay, they look into the potential of exosome as a regenerative medicine and targeted drug vehicle. So you would be surprised. Between year 1970 to year 2020, the publication on the exosome related topic increased drastically. Okay, so a message for researcher, for those who wish to look into the function of exosome, the application of exosome. Very important that we have to remember that exosome is produced by cell. It's something basic that being produced. However, when the cell is undergoing stress or undergoing damages, the composition of the exosome can be changed. Okay, so in another word, we can say that exosome can be potentially to be used as the tool for diagnosis and to monitor the disease management as well. Okay. Where we can get exosome? Where we can get exosome for research? Um, Basically, we can get exosome from plant. Okay, grape, ginger, lemon, broccoli have been reported producing exosome. Okay, those exosomes that collected. Okay, um, upon interaction or intake by animal models, they have role in upregulate WNT beta-catenin pathway, NLRP3 inflammation pathway, TLR4 TRIF pathway, TNF-related apoptosis inducing ligand signaling, and PKMTOR signaling. What does all this pathway means? Okay. The overall function, it will lead to sequential apoptotic events in wound healing, removal of inflammatory cell, granulation tissue into scar tissue, the migration of cell, the cellular proliferations will be enhanced, the antiviral function of the host will be increased as well. Okay. Okay, from mammalian cells, what are the source? What are the source you can get your exosomes? You can potentially get your exosome from mesenchymal stem cell, your neural cell, immune cell. Okay, the MSC derived exosome is common and famous among researchers. Okay, human, adipose, bone marrow, umbilical cord, synovia, embryonic stem cell, or induced pluripotent stem cell are the target of researcher. Okay, for immune cell, we can get exosome from macrophage, B cell, T cell, or natural killer cell. Okay, other source of exosome are the amount may be smaller amount, okay, but you're still able to get exosome from saliva, urine, lymph, breast milk, semen, amniotic fluid, aside fluids, bronchoalveolar lavage fluid, cerebrospinal fluid, and pulse as well. Okay, let's say today I have a flask of medium that I suspect containing the exosome that I want. Okay, what shall I do? Okay, how can I identify the presence of exosome in my medium? Okay, so we have to back to some basic. Okay, this is the exosome. On the surface of exosome, they are some important biomarker can be used. You can select MSC 1/2 in the crimes for tilling. CD9, 81, 63 are the common marker as well. And you can choose one or two marker from the exosome. TSG 101, H of protein 70 or Alex. You try to get a combination 2 plus 3 or 3 plus 2 to perform RT-PCR or the Western blot to confirm the presence of exosome in your medium. Okay. For further information, actually we can look into the outline from the International Society of Cellular Therapy as well. Okay. The essence part, the most important part of exosome definitely will be the component, okay, the RNA. Different exosome from different cell origin contain different microRNA and messenger RNA that determine the role of the exosome. Okay, today we are more specific on the wound healing. What could be the microRNA component or protein component that have effect on wound healing? Here we did some summary from a few studies, okay, to share with students and researchers. Okay. Exosome derived from adipose tissue has been reported. It containing nephrin lysine, microRNA 199A, 3P, 125A. For exosome derived from bone marrow, microRNA 199B, 218, 148A, 135B, 221, 126, 70-92 cluster, 133B, protein WNT3A. Okay, what are the pathway that will be upregulated? Okay, we do see some similarity. Okay, from the exosome derived from both adipose and bone marrow, the mTOR signaling pathway. Okay, the PI3K AKT signaling pathway, P10 PI3K mTOR signaling pathway. Okay. Others examples are the exosome derived from umbilical cord. Okay, they contain interleukin 6, interleukin 8, microRNA 455 3P, 24 106 19B, 25 181C. Okay. For another famous candidate, exosome from embryonic stem cell. It contains interleukin 4, 9, 13, 200A, CD73. Okay, all these are the potential components that enhance the wound healing. Okay, what could be the next technique? The technology can for enhance the application of these exosomes for wound healing. Okay, indeed, we can borrow some technology from libosome. Libosome is a more matured drug delivery vehicles. We can determine what to be load. The hydrophilic drug, hydrophobic drug can be load, and we can manipulate the surface charge and the protein to enhance the affinity of the uh, libosome towards a certain cluster of cell. Okay. Similarly, the application, the technique that mature in this libosome research, we can borrow from it. Okay. Do you think this is applicable? I'll say yes. Although, although it's not that mature, but there are a few successful report on exosome cargo, specific exosome cargo for targeted cell. Okay. Endocyanidins has been reported load passively into exosome, and it has affinity to various cell. Okay. Electroporations and chemical transfection. These are alternative procedures that you can enhance bleeding. Okay. And it should have affinity to H1299A549 cell. Okay. Application of biotechnical. We actually can express the desired cargo in exosome. Okay. And it's good news that this technique, it shows that it has affinity to various cancer cells. In another way, it can be helpful in the development of the special treatment on chemotherapy. Okay. The microRNA 133P that is present in the exosome from bone marrow MSC, it shows affinity to VISTA, red cortical neurons, and cerebral astrocyte. Okay. The exosome from umbilical cord MSC, the natural occurring cluster microRNA 24, 106A, 19B, 25, it show affinity. Okay. The exosome show affinity to endothelial cells, ovarian granulosa cell. Okay. The microRNA 1455P, okay, through the chemical transfection, the abundance of this cargo will be increased. Okay. And the exosome itself also shows some affinity to carbon 1, CFPAC, BXPC3, and PAN1 cell. Okay. Okay. So why we are focusing on wound healing? Okay. A lot of us think wound healing is just a natural process. All of us can heal easily, but I think we shouldn't underestimate the effectiveness in wound healing. You will be surprised that in this world, 7 million people are actually suffer from chronic and non-healing wounds. Okay, majority, 43%, they are suffering from the pressure ulcer, 31% diabetic foot ulcer, 12% venous leg ulcer, 7.8% surgical and trauma wound. Okay, what could be the reason that delay in wound healing? A combination of local factors and systemic factors. can be a reason for delaying the wound care management, the level of oxygen, infections, presence of foreign body, and the condition of the patient. Maybe they are obese, undernutrition, aging, or under medication. Okay, and for diabetic patients, a wound care management is very important for them. Okay, so we look into the events in wound healing. Okay, what are the events? Basically, it involves four different stages. Okay, hemostasis, inflammation, proliferation, and remodeling. The crosstalk between ECM, integrins, growth factor, and MMP is very important. Okay, when there is injury, the platelet aggregation will hemostasis will be initiated and followed by the platelet aggregations. Okay, various factor EGF, FGF, PTGF, all this will be released. Okay, and later on, the inflammation will take place. Inflammatory cell will migrate to the wound bed. Okay, and the major role, the cleaning role, okay, played by neutrophil, macrophage, and lymphocyte. Okay, at this stage, MMP, especially MMP2, play important role for the cleaning of the wound. You'll be surprised that for those who having the delay in wound healing, the dysregulation in MMP secretions is one of the factor. High level of MMP1, high level MMP9 has been confirmed that it will cause the wound healing process delay. Okay, so what are the alternative that we are having for improving the wound healing? Okay, these are the common approaches that we are using, we are applying: biologics, skin substitute, biomembranes, scaffold. Okay. However, it has some limitation. It could cause some low level toxicity, okay, and concern of the allogenicity, disease transmission, and pathogen transmission. Okay. For those chronic wound, MSC, stem cell therapy, could be an alternative, could be an option for them. Okay. How to deliver the stem cell to the wound? Okay. Four simple approach: bioscaffold, topical spray, injections, or systemic. Okay, these are the common practice that can be done. However, it could be quite costly and it will have some potential issue as well. The immunological rejections. Okay, the cell that we receive may have limited differentiations and the proliferation ability. Therefore, how good? It can't really promising on the wound healing as well. Okay, what can be done? A further step to have the effect of mesenchymal cell therapy and with minimum effect or without those side effect. Okay, when we think about mesenchymal cell therapy, it's actually applying the paracrine effect of the exosomes. Okay, therefore exosome that can be isolated from the MSC could be the next target. Okay. So do you think exosomes are better? I believe that it could be a better options. Okay. Both exosome and MSC therapy will activate signaling pathway that involve in cell proliferations, migration, and angiogenesis. Okay. Exosome itself, it contains more growth factors, triple growth factor compared to stem cell. And this actually is not immunogenic in nature due to the similar composition to our body. Okay. Okay. Next, we're going to look into the more specific role of exosome in wound healing. Um, okay. The first report that I'm going to discuss is from Zhu and their co-worker. In year 2013, they apply the plant-derived exosome, like nanovesicles, okay? And they found that application of this nanovesicle will activate OCT4 nano SOX2 make KLF4 transcription factor. These are the upregulated. And what is the effect of this? It transforms the mature differentiated cell into pluripotency. Okay, it maintains the sameness. Okay, the proliferation of the intestinal stem cell increase, and it promote long life intestinal organoid structures. So this is an example of a role of exosome that derive from plant cell. Okay, it show promising result for regenerative medicine. Okay. So in year 2003, the real and the co-worker, they found that the cell type from the bone marrow were found in the healed womb on day 21 after 1 cm diameter full thickness burn injury. Okay, major cell that found are fibroblasts. Okay, so their group, they reported that the proliferation of fibroblasts, okay, enhance the contraction of wound, deposition of extracellular matrix, and remodeling tissue. Okay, this is due to the activity of AKT 1/2 and STAT3 signaling. Okay, in both normal and chronic wound healing. Okay, from their research, the activation of STAT3, expression of gene involved in cell cycle control and encoding growth factors. These are the role of exosome in wound healing in their study. Okay. Okay. Just now, the exosome is from bone marrow. Okay. Another group, Ding and the co-worker, they use the bone marrow MSC derived exosome as well. Here, they look into the cutaneous wound healing effect. Okay, look at this picture. The last row is a control. Okay, this is a normal healing. Okay, on day 14, the wound is not wound 100%. Okay, maybe about 70% healed. Okay, the second row, they isolate and concentrate the exosomes from the normal media, and they did injections on the target area on day 14. Okay, almost the wound heal, about 10% or 20% left. Okay, they have another set of exosome that derive from special condition. They add deferosamine, okay, as a medium to enhance the productions, okay, of the exosomes. Okay, the exosome that isolate and apply in this wound, it shows that on day 14, almost the wound is completely healed. Okay, what is the mechanism of this exosome wound healing effect? Okay, they found that the endothelial cell of the recipients, okay, therefore the elevate of 100 microRNA 126, okay, and this is related to the mechanism of angiogenesis. Okay, so from their From their project, they found that the direct interactions between the exosome and their target cell transfer the exosome cargos. The crosstalk between them is through the exosome cargos. Okay, it promotes the vascularization through PI3K AKT pathway, and it enhances the recovery of the diabetic wound healing. Okay, I think this is the fourth project that reported by the McBride and their team. Here, they also use the bone marrow MSC derived exosome. Okay. Here they use they try to get exosome from two different conditions. Okay. This is a normal conditions. Okay. And this is a condition with expression of WNT3A culture. Okay. We look into the control media. The control media, this is a scratch assay. Okay. So after 1 day, okay, the control media without presence of exosome, the gap closure is not observed. Okay. For sample, after scratch assay, the presence of the exosome, okay, in the normal media, they observe gap closure. The last row, for sample under scratch assay, with presence of exosome with presence of WNT3A protein, the gap closure is further enhanced. Okay, here they found that with presence of the WNT3A protein, it will enhance the role of exosome. Okay, and they confirm the role of exosome in stimulating the wound healing. How does it work? Through the activation of the WNT-p-catenin pathway. Okay, it enhances the fibroblast proliferation, migration, and angiogenesis in vitro. Okay, so from here I only reported 4 studies, but from overall report, we will see and confirm that the exosome very crucial in the modulation of signaling pathway and cellular communication through the angiogenesis fibroblast proliferations. Okay. However, because different researchers will have different focus, and how are we going to connect those pathway? How are we going to connect it to have better understanding application of exosome for the cell-free therapy? What we are doing. So here, our group will try to look into a few biotools, okay, the gene ontology enrichment analysis, the KEGG pathway, the Derived database for annotations, visualization, and integrated discovery, and apply those targeted into the protein-protein interaction network. Okay, what we get from those present study. Okay, this is the mapping, the protein-protein network mapping that we obtain from those reported research. Okay, so from here, what we can understand better, we can look into the molecular functions and the biological functions. Okay, so here in this slide, this is the molecular functions that from those projects that reported. The overall molecular functions, the top 5 functions are the receptor-receptor interactions. Okay, so this is related to crosstalk. Okay, the BH3 domain binding. Okay, mismatch DNA binding, protein kinase A catalytic subunit binding, GTPase activating protein binding. This is what we get from the mapping. Okay, for the biological functions, what do we get? Okay, we get negative regulation of blood vessel endothelial cell proliferations related to proliferations involved in sprouting angiogenesis, positive regulation of melanocyte differentiations, positive regulation of neuron maturations, negative regulation of long-chain fatty acid import across plasma membrane, negative regulation of cell side. Okay, so okay, this is what we can understand from those current research, and from here, actually, we can identify the potential gap. This is a common, I mean, approach that recommended and suggested. We can look for some potential gap in between. That is a way that we can propose a new project as well. Okay. Okay. From these sharing sessions, again, I would like to highlight that uh, we all understand that the complexity of exosomal cargo. It contains cytokines, the enzyme growth factor, signaling lipid, microRNAs, the regulatory microRNAs, and the exosome cargo could be different, okay? Under different physiological or pathological conditions. The modeling combinatory analysis that I show, that I suggest, can be an alternative strategy to advance our understanding on how the specific exosome cargo contain regulate processes. Okay, from this point, we can have a better understand on the therapeutic potential of exosome in wound healing and the network interactions between a functional and exosome cargo contents. Okay. Um, I would like to take the opportunity to thanks really thankful to our Dean, Prof. Rosna, okay, my collaborator from University of Malaya, Associate Prof. Dr. Ivy Chung from the Department of Pharmacology, and my collaborators, Dr. Tan, she is a chemist who helping to develop and especially on the liposome. And from Masa University side, I would like to thank to my colleague, Dr. Uida Jins. We are all doing the same exosome based project, and my research assistant, Mickey Chu. And again, thanks for the grant that we received for this project. Okay. Actually, I would like to use this platform to do enrollment, employ. Actually, we need 1 or 2 master students for this project for about 2 years. The project will be based in the PPUM. Okay. For those who have interest to do project on the exosome related prospect, you may drop an email to me, Dr. Ivy, or Dr. Dan. Okay. Thank you.
Thank you so much, Dr. Fong Fong. This was really a very nice explanation of a complex topic. So, a complex research topic is explained in such a lucid manner. So, you see, exosome can be used as a cargo for migration, transportation, storage in the wound environment to facilitate wound healing. This is really very exciting field to work on. So I will invite the interested candidates to please apply for this position that has been put forth by Dr. Fong Fong. So thank you, Dr. Liu Fong Fong. Thank you, everyone, for viewing this, for supporting us. And we will come back with different, more interesting topics on research, on clinics, and on teaching in our next webinars. Thank you, everyone. Stay safe and take care. Thank you for watching. Thank you very
Thank
much.
you.